This is a water bear, one of the most resilient little guys we've ever seen. This is a gross little mite, one of the things we probably don't want to see. And this is a virus, something you don't want to interact with, but something that with continued research we're learning more and more about. And how we see and learn about all these things is through microscopes. And in this video, we're going to take a look at 5 different types of microscopes: simple, compound, laser scanning, transmission electron, and scanning electron microscopes. Let's take a look at microscopes. Okay, so off the start, there is light microscopes and electron microscopes. We're going to start with looking at light microscopes. They are relatively cheap, much cheaper than electron microscopes, but they are limited in their magnification and resolution. Let's start with the most simple microscope, which is simply called a simple microscope. And this microscope was used a long time ago. It was used by Hooke and Leeuwenhoek a long time ago using just one lens. And it's kind of, as much as it's simple, it's kind of a really interesting setup where we've got this kind of microscope looking part over here, but then the light source over there with a lamp and then a ball of fluid or a ball of water here to focus that image down, or it could be a ball of glass, but as I've seen in some research, they actually used water to try and focus that light there to make it bright on the image. And then they tried just where it was to try and focus the image, but yeah, just use that one lens that they were looking through. So fairly simple. It only had, again, things to remember: one lens, about 50 times magnification, which for nowadays, that's not that good. Back in the day, helped them to learn a lot of things. And again, because it's only one lens, this would be the cheapest of the microscopes. Next one is our compound microscope, which is probably one that looks a bit more familiar to what you would see in a classroom, and it uses 2 lenses. There's lots of parts here, and they could ask you in class what the parts are, so let's go through some of those. The first lens on that side is the ocular lens. It's usually about 10 times magnification, and that's what you're looking through. And then there's the objective lenses down there that you can rotate through different magnifications. That's the big jump from a simple microscope to a compound one. 2 lenses, which is going to increase our magnification and make focusing easier. Take a look at some other parts of it. There's the stage, which you set the specimen or the thing that you're looking at on. We have the light shining up through the bottom. And then while you have the arm on this side, it's not really an important part for zooming in, but for when you're carrying the microscope, it's important to have a good grip on it, the solid piece there that's not fragile. The coarse adjustment, that's when you're moving the stage up and down quite quickly with big adjustments. Usually only use that at low power objective lens. But then the fine adjustment, when you're on that high powered lens and you just want to make tiny little adjustments, then you use the fine adjustment there. So the ocular lens usually is going to be 10 times, but we could have options, maybe a 5, 10, and 40 are pretty common options for the objective lens. And it could ask you, like, if you're using the 10 and you're using maybe the 40, what's the overall magnification of the microscope? Do I add the 10 and the 40? Do I multiply them? Yes, you're going to multiply them. So say we're at 10 and 40, we multiply those 2 numbers, we'd say it's a 400 times magnification at those settings. So things to remember: increase magnification with the 2 lenses, and you're going to have better focus with those 2 lenses. Okay, last one for light here is our laser scanning microscope. This one seems the most intense, and it kind of is the most intense. I have a small picture of the bottom there. We're going to try and scan this image that has some depth to it. Instead of just looking at the surface or shining light through it, because it has to be pretty thin to do that, it's going to try to scan it in layers. So I have a bit of an animation here. I'll pop out of the way. So it's going to scan the image. We see the top part here, then a little bit further down, a little bit further down. It's going at different depths to try and build up a 3D picture of this image. So here's some pictures just that I found from Google for what that kind of looks like, and finding the different layers and then putting them all together. That's its biggest advantage, that it has a 3D image, but it also is more magnification. It's about 1,000 times. Again, there's lots of variance in these different types of microscopes. There's a range of what they could magnify. So I'm going to put approximate magnifications just so you can kind of see as they move up as we move through the microscopes. But there is some variances through each type. Okay. Also building a 3D image. Those are 2 main things to learn from this laser scanning microscope. Okay, that's it for light microscopes. We're next on to electron microscopes. The operation of electron microscopes requires some science that is beyond Science 10 that we're looking at here, the grade 10 level, but we'll start to introduce kind of the basics for how it works. So how it works is we're basically, instead of shooting light, we're going to shoot something that has a smaller wavelength, but the wavelength of electron, that comes up later. So we'll just say we're shooting something smaller. So shooting something smaller gives us a better picture of what's coming back. So this isn't exactly how it works, but it's a good analogy. Let's take a look at this animation here. We're going to look at light on that far side. And if I was shooting photons, which is little particles of light, it might kind of look like this. A light ray goes down, bounces back up, and it gives me information for where that surface was. So I'm scanning this really bumpy surface down here. The light bounces off and comes back, and I get approximately what that surface looked at there. Imagine this is really, really small. These bumps are really, really, really tiny. So I keep scanning with my light's going and bouncing back, and it's building a picture of kind of what this surface looks like. So those green lines at the top, they show kind of the ups and downs of the gray part down here, but it's not super detailed. It gives me a decent idea of higher and lower places, but it's not that accurate. Because when I was shooting the light in, I'm going to go back, it's kind of large. That's the wavelength, that's kind of large there. Another issue that happens is when you look at really small things, there can be some refraction, but again, that's getting a little bit beyond our science or grade 10 level. So just imagine that we're shooting something larger and we're getting kind of a not super detailed image. We get some information, but it's not super detailed. What we're going to do is we took something smaller like an electron. That's going to happen over here. I shoot something smaller. It comes down, bounces off, and I get my information about that location a little bit better. I shoot a whole bunch of these little things. We can see it's going down and giving us information. Because the electrons are smaller, the purple lines, they're still not quite exactly like the gray one is below, but it's a lot more detailed. We can see it follows the curves much better. So if we're to compare these two, the green one for the light here is good, but the electron one much more detailed. So that's how we're going to get better magnification and resolution with electron microscopes. And the first one we're going to look at, a transmission electron microscope. A transmission electron microscope takes electrons and it focuses them through this kind of magnetic lens so it can focus down onto a specimen. So again, you won't need to know quite this much detail, but for interest, let's look at kind of how this works. It was in that kind of clip there, but we have our electron gun, our source of electron, they're being pulled towards our anode, and we have these condenser lenses, a specimen, and then builds an image after it's passed through the specimen. So transmission means it's passing through, and then we're building up this image on this fluorescent screen. That's really all we need to know, passing electrons through for this level. Again, you could do much more in-depth videos on this, but this is meant to be very surface level, just passing electrons through. Okay, so important things to know there. Electrons are passing through in this case, and we get incredible magnification. About 50 million times magnification. The last one, the laser scanning, was about 1,000. 50 million times magnification gives a really cool image. This is that kind of look like this or like this, and just enable us to see a whole bunch more things. And on to our last one, another electron microscope is the scanning electron microscope. The picture looks pretty similar, but instead of this big long column, we have more of a chamber here. And you can see in this video, you can open up the chamber, put specimen in there, turn on the electron microscope and use its computer to kind of look around, find your specimen, and then zoom into, again, a very big amount. Looking for just a little bit of detail for how it works, instead of passing the electrons through, the electrons are going to kind of bounce off. They're going to get ejected. You can knock off electrons from the specimen, and there can be bouncing off of the original electrons you shot. There's a bunch of electrons coming off. But for simplicity, at this grade 10 level, we'll say they're just being ejected or bounced off. Okay, so they're being bounced off like this. But another big benefit to this one is it also is going to give off some light, and maybe not visible light, but X-rays or other things that are going to tell us actually information about what we're looking at. Because we're knocking off electrons and there's transitions between the two, that gives off almost like a light or a radiation fingerprint to tell us what we're actually looking at. So that's actually kind of a cool advantage of this type of microscope. You can tell what chemicals you're looking at. So you're looking at a piece of jewelry. Is it actually gold or is it made of a different metal? You can figure that out with the scanning electron microscope or anything else you're looking at. So a little bit of a different microscope. It's ejected electrons instead of passing through. The magnification is a little bit lower, 1.5 million, which is still a ton, so you still get some really cool images. And the images are a bit cooler because they can be 3D images, and again, you can tell what the chemicals are that are going to make them up. So those are some advantages to the scanning electron microscope. And that's all we have for this video. So a rather quick one, but I hope that helped you to understand the difference between those types of microscopes. If you're looking for more videos on science, we have playlists of entire courses here, and there's just the latest video over here. Thank you again so much for watching, and I will see you in the next video.